Hi, future doctors. Welcome to the next class. We were discussing potential gradient problem. So let us assume potential is given x by y. In previous class, we discussed the product, some additions we did. Now we will see division. Potential is equal to x by y. And find the electric field intensity at 1, comma 1, comma 1, or at origin they will ask. If they are asking at origin means what is this value? 0, comma 0, comma 0. So first we'll find this one like this, x y power minus. What is Ex now? Ex is nothing but minus dou v by dou x. Minus dou by dou x of. What we have to substitute v? V is nothing but x y power minus 1. With respect to x we are doing, therefore y we will write outside y power minus 1. Dou x by dou x is going to be 1. Therefore, Ex is going to be minus 1 by y. Now, Ey we will see. So, what is Ey? Minus dou v by dou y. So, minus dou by dou y of what is v means? Now, v is going to be x y power minus 1. Now, with respect to y you are doing, therefore, x you can write outside. Minus x dou by dou y of y power minus 1 minus x. What is derivative of x power n formula? Derivative of x power n is n into x power n minus 1 dx. With respect to x means x will be cancelled. Therefore, with respect to y, therefore minus 1 into y power minus 1 minus. Minus into minus plus x y power minus 2. Correct? X y power minus 2. But we are getting which sign? Positive sign here. So this one only they will write x by y square. Now final answer. E bar is equal to 1 comma 1 comma 1. So Ex I cap plus Ey j cap. What is Ex? Minus 1 by y. What is Ey? Plus x by y square j cap. Already with negative signs we have taken directly, we can write here. Now what is y value? 1. Minus 1 by 1 I cap plus 1 by 1 square j cap. Therefore, minus I cap plus j cap. This is electric field intensity vector form. If you want to find magnitude, what is magnitude of E bar? That is going to be root minus 1 square plus 1 square. Root 2 Newton per Coulomb. So this is going to be how we calculated electric field intensity in case of division. Like this, they may give so many potentials, x by y square, xy by z, like this. All these you can do like this one. So I hope you understood. Next, we will see potential due to dipole. Potential due to dipole. Before going to series, potential due to dipole. So if you want to see another problem on this, simple problem. So they will give voltage values like this. So 0 this is, minus 10 volts, plus 10 volts, 20 volts, 30 volts. So each distance they will give this value. They will give 1 centimeter, 2 centimeter, 3 centimeter like this. Now what is the electric field intensity for this problem? Find electric field intensity. Okay, they gave potential difference. So in which direction it is decreasing means downwards. Therefore, what is the direction of electric field? We said in the direction of decreasing potential, downwards. Downwards means minus j cap. Correct? So they will be asking questions like this. Downwards means minus j cap, direction of electric field intensity. Now what is the value means? dV by dy because along y-axis. What is dv? 20 minus 10. 20 minus 10 means 10. What is dy? 2 centimeters minus 1 centimeter. 2 centimeter minus 1 centimeter means what you are going to get? 1 centimeter. 1 centimeter means 10 power minus 2. So if you want to write another minus dy by dy, this is minus j cap if you want direction. So this is finally you are going to get 1000, isn't it? 1000 Newton per coulomb magnitude. So like this, they're going to ask the problems. Even though in this direction is also very important, in which direction electric field intensity is going to be present. Okay. So like this also they're going to ask the problem. So be careful while solving this type of models. Next, potential due to dipole. So what is dipole? We said one is positive charge, another one is negative charge. Two equal and opposite charges separated by very small distance is called dipole. So at any point which is at distance, r by making an angle theta. So what is the dipole at this point means? So our formula is Kp cos theta by r square they will write. Now what is this theta? How we are going to calculate potential? So what is the direction of dipole moment we said? Dipole moment direction will be always negative to positive. So this r and dipole moment both are in same direction. We will see how it is going to come. So dipole moment is like this. Dipole moment is like this means here negative charge, here positive charge. We are taking point on axial line here. Now this is the distance. So distance direction will be how it is coming. Distance direction like this. Means this point be in right side direction. Now what is theta? Theta is going to be 180 degrees. Then what is the potential at this point? Kp cos 180 by r. So minus Kp by r. If you are taking point this side, point P this side, or P1 you can take, P2 you can take because P dipole moment is coming. P2 is this side means now this is the distance direction. So this is the distance direction means now both P and R bar in same direction. Now at the time potential at point 2. This is potential at point 1. Kp cos 0 by R. Kp by R. Now if you are taking point exactly on equatorial line here, P3. Now what is the angle means here? 90 degrees for R and P. Isn't it? Sorry, here. Here we have to. This is dipole. P3, not here. Okay. Now this is R. What is the angle means now? 90. 90 means Kp cos 90 by R square. What is cos 90? 0. So this one only we can remember very logically. If dipole is like this given, let us say right side direction. Dipole like this they have given. Now here negative charge, here positive charge. If you are taking an axial line near positive charge, then potential is going to be positive. If you are taking near negative charge, then potential is going to be negative. If you are taking on equatorial line, okay, potential is going to be 0. Therefore, we will say this line. So which line? This equatorial line. So at equatorial line, potential wherever we are taking it is going to be 0. So but this line is having same potential. So the same potential, that value is going to be 0 volts. Therefore, this line we will call equipotential line. If you place any plane here, this plane we will call equipotential surface because potential is going to be same, that is 0. So already we discussed equipotential surface. Therefore, how they are going to ask question means they placed a dipole on equatorial line. A charge is going to be placed at one point and it is moved to another point on equipotential line. Then what is the work done they will ask. What is the work done means 0 because W is equal to Q into VA minus VB. Potentials are same, therefore work done is 0. Already we discussed. So potential is going to become same means work done to move the charge on the surface is always 0. Now what is the direction of electric field? So dipole moment is always negative to positive. Negative to positive. If you want on at center of the dipole, what is the electric field intensity? What is the electric field intensity because of positive charge means away. Because of negative charge, towards. Therefore, both if you add, resultant will be coming like this. Correct? So electric field intensity direction is always making 90 degrees for equipotential line. Okay. If you are taking any equipotential surface, for that surface, electric field intensity always makes 90 degrees angle. Electric field intensity direction always perpendicular to the equipotential surface. So already we discussed for point positive charge. So what is the direction of electric field means? Away. Now what is the equipotential surface? Spherical surface. Therefore angle between these two is always going to be 90 degrees. Blindly you can follow. So I think you understood potential when we have to take negative, when we have to take positive. Obviously on equatorial line potential is going to become 0. Near negative charge means potential always negative. Near positive charge means potential always positive. Near positive charge means potential positive. This is the equation for potential due to dipole. So we can prepare well by remembering these formulas. We will see in next class.